Good afternoon and welcome to these CWIEME Tech Talks about the role of the electric motor in the transition towards zero-emission vehicles. I'm Alexandra Martins and I'm CWIEME Berlin Senior Content Manager. We are delighted to have you all here joining us today. Hope you enjoyed the presentations and connecting virtually with your peers. Before we get started, I would quickly like to go over a couple of housekeeping points for this session. If you have any questions, please ask them in the Q&A tab on your right-hand side, and we'll share them with the speakers. This webinar will be available on demand after the session. The slides can be downloaded on our website. I'm pleased to introduce our speakers, Michael Southcott, Manager, and Kartik Ganesh, Senior Research Analyst in S&P Global Mobility. I will now hand over to our speakers. Welcome, Michael, and welcome, Kartik.
Thanks, Alexandra. Great to be here again, doing another session with yourselves at CWIEME. We normally attend in person, but great to do this webinar today. So as it says, we'll be looking at the role of the electric motor. Myself and Kartik will explore some of the technical attributes, some of the supply chain elements that are impacting the entire motor value chain across battery electric and hybrid vehicles, obviously with the sort of, let's say, the slight slowdown in battery electric sales that we're seeing in 2024, or maybe in the next coming years. The hybrid based motors will be particularly important. So as the title says, and I've just explained, the electric drive value chain. Like I say, my name is Michael Southcott. I'm a manager here, and Kartik is a senior analyst in our supply chain and technology team at S&P Global Mobility. So in terms of the agenda today, we'll look at the growth of the electric vehicle market, and in particular the electric motor market as a consequence. We'll sort of analyze what's happened in the last 12 to 13 months. There's obviously been a lot of industry noise around maybe slowdowns, maybe a shift in consumer sentiment. And then Kartik will run us through some of the technical elements behind it in terms of looking at things like power density, copper windings, efficiency, and a few other technical parameters that are being influenced by these trends. And then we'll loop into some of the supply chain elements and where the sort of role between OEMs and tier ones and even tier twos fits into this complete supply chain. So before we dive into the electric motor technical parts, I just wanted to pull out these couple of slides that we have from our consumer survey that we run here at S&P Global Mobility. So we speak to clients of ours, and there's about 6,000 of them globally, and we ask them a range of questions covering anything from electric uptake to autonomy to anything and everything within the world of automotive. These two questions are around sentiment towards EV purchasing. So it's broken down into two categories. On the left, we have the previous owners, so people who've owned an electric vehicle. What is their sentiment now towards repurchasing an electric vehicle? They've shifted away from it. Why, would they purchase another one? And on the right, we have what we call EV intenders. So they intend to purchase an EV. They would like to purchase an EV, but maybe they haven't made the jump. And why haven't they made the jump? And I think it's important to look particularly around, we've highlighted here previous owners. For previous owners, the sentiment around charging is really, really the driving force for them not coming back now to purchase an electric vehicle. The feeling from 2022 to 2024 amongst that segment of clientele is actually getting worse. It's now around 50% say that the time required to charge is just simply not good enough. Amongst EV intenders, the perceptions pretty much remain the same. You see there's some small drop-offs maybe around pricing and range, but fundamentally the sentiment amongst consumers towards purchasing a battery electric vehicle is not really improving over the last 2 to 3 years. And I think that's really important when we move forward and we think about how we continue this path towards battery electric. We have to get the end consumer to understand the improvements that have been made, but also listen to them around what their concerns and feelings on the industry still are. And we're on this transition. So as a propulsion system, which is obviously what I work on and what Kartik works on, it's really a legislation driven sort of transition at the minute. You can see at the top, and we've only picked out a few of these globally. There's many, many, many more at a global level that are driving us towards hybrids and towards sort of zero emission vehicles. Let's say the intended target in the next decade or beyond. And as part of that, there's a technology transition. And I think the important thing to remind ourselves with this webinar focusing on the electric motor is the electric motor in some form, once we've moved away from a traditional ICE and we're into, say, a 48 volt mild hybrid, from there onwards, the electric motor plays a role, be it a small electric motor, like I say, and a 48 volt BSG, right through to an 800 volt battery electric twin front plus twin rear e-axle setup. The electric motor has got a really, really big, important role to play as we move towards, these legislations kicking in and we end up towards zero emission vehicles at some point in the next decade or beyond. So let's look at the electric motor market and what's actually happened here. So this is focusing on e-axles in battery electric vehicles only. So you can see in the summer of 2023, the trajectory was pretty much a straight line. I would say it was on a relatively linear trajectory, and we were going to end up somewhere around 80 million e-motors within an e-axle being produced by 2034. What we've seen this year is this slowdown in the production of e-motors for e-axle usage. We still then see this sort of linear transition once we get past this year. And we think, certainly if we take somewhere like Europe, when we move towards 2025 CO2 numbers, this sort of push towards selling them and usage of battery electric vehicles will see motor production ramp up again. There's also been a leveling out of inventory in Europe that's maybe impacted some of the production levels, trying to bring it aligned a bit more to sales and production being aligned a bit more. So we still see a really big trajectory here of growth outwards to over 70 million motors being produced for P4 applications. But there's certainly been this sort of slowdown between 2023 to 2024, but we think that will start to recover itself next year. In terms of hybrid vehicles, so this is looking at non-P4 applications, so anything that's not an e-axle. This is where we've really seen the real sort of shift in the longer term forecast that we're seeing. So it's in the press, it's been spoken about a lot that hybrids are making a comeback. Yes, they are. We still see a trajectory towards battery electric in the major automotive markets of North America, Greater China, and Europe. But hybrid certainly seems to have a lot more of a bigger role to play. You can see if we look towards the end of this decade, around 2029, 2030, we think around 10 million more motors will be used and produced for usage in hybrid vehicles that are non-P4 applications. It looks as if sort of 2023 to 2025, not a lot's happened. There has been a bit of a shift in a bit of a ramp up in hybrid production in China and a bit of a slowdown in the production in Europe and North America that sort of leveled the two out. There is some nuances behind this, but certainly I think as we look towards the end of this decade and beyond, we're now seeing more and more usage of non-e-axle motors in electric vehicles, or in hybrid vehicles, I should say. So where is all of this going to be produced? So let's focus on e-axle motors only. Greater China is going to dominate the production of e-axle motors. It already does. It's probably just exceeded 10 million motors this year in terms of being produced for e-axle applications. And we think it'll exceed 30, approaching 35 million by the time we get to the middle part of next decade. Europe and North America then has a pretty big ramp up on production of these coming in the next couple of years. They approach around just over 15 million motors being produced each by the middle point of next decade. Quite a big ramp up from North America. You can see they're sort of lagging a little bit behind Europe in terms of the production of these, and behind Japan and Korea, and particularly this year and next year. But then from 2027 onwards, you can see the sort of big jump up that they have, and they sort of run parallel to European volumes throughout the latter part of this decade and into the next decade. So one other thing to look at here is the usage of e-axle in hybrids. So more around sort of plug-in hybrids I should emphasize the scale here that we're looking at. The total e-axle market that I showed on the first slide was sort of a 70 to 80 million peak. This is only 4 million, but you can see this jump that we've had in the usage of P4 applications in hybrid motors, so sort of the plug-in hybrids that we see. Like I said, we're still only approaching maybe 4 million units by the time we get to 2029, but that's a doubling of what we expected it to be in the summer of last year. So P4s being used in hybrids is definitely something that we're seeing as more of a trend as we go through this next decade and beyond as well. So let's focus on the production of non-e-axle motors. So I touched upon earlier, we've seen this sort of 10 million growth towards the end of this decade of the jump from 2023 to 2024. Where will they be produced? So at the minute, Japan and Korea lead the way last year and this year in terms of non-e-axle production. We think China will look to overtake them, or will overtake them next year and beyond. But then we see Japan and Korea having this sort of longevity of hybrid motor production. Obviously, it's quite a strategy from their OEMs to keep hybrid for as long as they can. And we see maybe the drop in the production of this in Greater China as they sort of really move towards heading towards a larger percentage of battery electric vehicles towards the end of the decade and beyond in Greater China. A bit in Europe, but you can see this tail off in Europe. That's as we head towards 2035, or what's probably going to be pushed back to 2040. ICE ban in inverted commas. So you can see the production of European motors is going to drop throughout the end of this decade and certainly into the next decade. So one of the trends, and certainly with the US election that's just taken place, I think one of the hot topics is in most of the segments of the automotive industry and component segments is regional independence, regionalization of production. So imports and exports of electric motors is going to be really important. Let's focus, I touched upon just there, Japan and Korea. Japan and Korea will be pretty self-sufficient, very, very, very small amount of imports coming into the region and a large amount of exports, particularly going to Europe, to China and to North America for their hybrid production motors. Small amounts on the e-axle there from Japan and Korea. It's predominantly going to be the hybrid portion. You can see Europe, it's about even between imports and exports. It does flatline the number of imports that we're going to see as we get towards sort of the early part of next decade. A chunk of that is around sort of, we think European production will start to flatline as well at the vehicle level, but maybe we do see some more exports on the bottom. A chunk of that maybe being Chinese companies, Chinese suppliers setting up in Europe and looking to export globally. For Greater China, there's a little bit of a kick up in imports. That's mostly around some of the Japanese OEMs who are entering the market. We think they will look to still source in Japan potentially. That could shift depending on the way in which sort of legislation and policy making goes. For North America, I think the big trend there is the import levels that we see. It will peak around 2028. The number of imports that they will need, the investment that's happening, and we touched upon it earlier that there's going to be this big ramp up of e-axle production. North American imports will decline throughout the latter part of this decade and into the next decade. So heading very much towards regional independence, and potentially these numbers will shift even more. Let's see what happens in the policy making over the next couple of months and years. On that note, I will hand over to Kartik, who will begin talking about some of the increases in power density and the trends there.
Thanks, Michael. Hello, everyone. So over the next few slides, we'll be discussing about some of the technical parameters that influence decision making when it comes to choice of electric motor selection. So let's begin by talking about increasing power density or specific power. So the idea behind specific power is to optimize the power output in relation to the size and the weight of the motor, because this helps in improving the energy efficiency and therefore helps extend the range of the vehicle. So due to these factors, a lot of motor designers have started giving a lot of importance to specific power. If you see the chart on the right hand side, we see that when suppliers move from one generation to the other, there has been a significant improvement in specific power ratings, and different suppliers adopt different methods to achieve these improvements. Across the industry, this has been observed to be at about 35% on an average, while the range lies between somewhere between 20 to 40%. There are three key strategies that suppliers are following when they want to achieve such improvements. The first strategy includes a choice where they increase the power of the motor but maintain the same weight of the motor. The second choice is one where they retain the same power rating but reduce the weight of the motor. The third is a concurrent strategy where they aim to increase the power while reducing the weight of the motor. If you see the chart on the bottom on the right hand side, we will observe that these changes over different generations are happening with various motor topologies. It's not something that's just specific to any one particular technology. As indicated, as different topologies are witnessing improvements when we move from one generation to the other, it has been noted that PMSM or permanent magnet motors typically exhibit greater specific rating when compared to other forms of motors that do not use rare earth elements such as induction motors. And whenever suppliers are trying to move away from permanent magnet motors, their main aim is to try and match the power ratings that the permanent magnet motors offer. So while trying to do so, there are certain trade-offs that they need to tackle, and these come in the form of parameters such as weight, efficiency, etc. If we look at the chart on the left-hand side, we see what different suppliers are trying to do with the yellow bubble indicating a permanent magnet motor, whereas the green one indicating an induction motor, and the size of the bubble indicating the specific power rating. So for example, if you take supplier 1, while trying to retain the same power rating, supplier 1 has to significantly increase the weight of the motor, due to which the specific power rating drops. Whereas supplier 2 has managed to maintain a similar level of specific power, but has increased the power and the weight of the motor. And same goes for supplier 3, who's also had to do the same, but has to significantly increase the weight and the power rating just to ensure the specific power rating remains the same. So if you look at the chart on the right hand side, we're just giving you a perspective of how the industry or where the industry is headed towards. So this chart gives you a scatter of power versus motor mass. And we see that there is a downward trajectory that exists here, which indicates that a lot of suppliers are trying to increase the power of the motor and at the same time reduce the weight of the motor. We believe this would be the most, say, go-to solution at this point in time, but as this reach saturation towards improvements, they will start focusing on individual parameters such as just mass or just power when it comes to improving the specific power rating. Another key parameter that has been getting a lot of attention of late is the e-motor speed itself. So when we talk just about the e-axle based motors, we believe that by increasing the operating RPM of the motor, in certain instances we can yield better performance, which will be around power density and efficiency. For quite a long period of time, it has been believed that the limit for mass production motors in terms of motor speed is set at 20,000 rpm. But due to recent developments where thermal management has improved and thanks to improvement in even manufacturing technologies, the boundary of 20,000 is being further pushed up. And if you look at the chart here, in 2023, only 2% of the market accounted for motors that could run beyond 20,000 rpm. But this number significantly increases to about 23% by 2035. Another key attribute that needs to be taken into account when we talk about electric motors is copper winding. So these copper windings form a key part of the electric motor and need thorough consideration when it comes to design. So we've listed down some of the key winding topologies that are used on electric motors here. So insertion winding was one of the most common forms of winding technology that had been adopted in the electric motor space, and it still continues to occupy a large portion. Hairpin winding is an extension or an improvement on it, where square wires are used instead of traditional round wire. Due to better fill factors, this helps improve the efficiency of the motor. Continuous wave winding is an extension on the hairpin winding, where the welding processes are eliminated, but on the whole, the manufacturing process still remains a little complicated. A lot of suppliers and OEMs are trying to explore this option because there are certain benefits that could come out of it. Concentric spool is a technology that's more common to hybrid applications, P2 in particular, But in the case of e-axles, there are certain motor topologies where rotor windings are going down this route. IPIN is something that has not witnessed that bigger growth in the e-axle application case, but there are some tier ones who are exploring it, and it seems to be more of a say niche application for high performance variants only. XPIN is a new emerging technology that has come out of Greater China, and as the market picks up in Greater China, we believe this would eventually spill over to other regions of the world as well. So, as indicated, hairpin technology has become more of a say go-to solution whenever electric motor design has come into perspective, and this is primarily driven by the growth of e-axle market itself. Europe and North America in particular are witnessing quick ramp ups in hairpin production lines in the short run so that they can improve the or match the performance that is necessary. If you see the chart on the left hand side, it gives us a good perspective of how the hairpin winding is likely to be the most say dominant form of winding technology if we look up to 2036. Certain other winding techniques such as X-plane and continuous wave are key technologies which one needs to look out for in the mid and the long term. And we believe X-spin is a regional phenomena that is occurring in China, and if there is wider adoption of it, it could potentially expand globally. And if you see the right hand side chart, we've just indicated three key regions, namely Europe, North America, and Greater China, and split it over 6 year intervals just to understand how the market is shifting. And we do see that the winding technology significantly reduces when it comes to insertion winding, and the growth of hairpin is very well evident there. And Greater China market seems to be the unique market because there are a wide array of winding technologies that are likely to be adopted as we go forward. As we spoke about copper, it's important to understand the amount of copper that goes into each of these motors. The intensity fluctuates based on the motor topology that a supplier is looking to adopt. And this usually ranges somewhere from 2 kgs to about 18 kgs, depending on the level of performance necessary. So typically, an increased power output correlates to a greater requirement of copper within the given motor itself. And the motor, when we speak about, say, a permanent magnet motor, the demand basically stems from the stator itself. Whereas there are other motor topologies such as induction motor and EASM motors that exhibit much higher requirement of copper because of the usage of copper both in the rotor and the stator as well. And as the industry tries to look at other alternative motor topologies that can be used within the electric vehicles, we expect the industry demand for copper to increase as time progresses. To give you a glimpse on how the copper demand is varying, we've just put out this chart in front of you. We've compared a couple of forecasts. One is the most recent forecast that we've published, and one from 2023, just to give you a glimpse of how the market has evolved over the course of the last year. On the whole, if you look at the trend over time, copper demand is expected to increase as the e-axle market grows. The latest forecast indicates a slight decline in the copper demand when compared to last year's forecast. This is attributed to the slowdown in the adoption of battery electric vehicles. The drop is more significant in the short run. Up to the first 3 to 5 years, it ranges somewhere between 7 to 15%. But as time progresses, the disparity between the two comes down. And by 2035, both of them merge to the same initial values that we had observed in the last year's forecast. A couple of key other parameters that we need to look at is our efficiency and the motor topology. What role do these two parameters play? So efficiency for any system is crucial, and when it comes to electric vehicles, it becomes even more important. So any efficient system makes use of less electrical energy while sustaining the same level of performance. With developments and advancements in power electronics and motor technologies, these two steps help mitigate the stress on electric vehicle batteries, therefore extending its life. So if you see, most suppliers are keen to adopt PMSM over say other topologies because these particular motors can yield at least 2 to 5% improvements in efficiency. At the same time, the adoption of silicon carbide based inverters has shown to deliver further improvements when it comes to the component level. Now, when we bring all these components together, all the impact of all these efficiencies then has a very good improvement in the system efficiency as a whole, which then helps translate into better vehicle range. To give you an idea of what different suppliers are doing, we've just put out this chart on the right hand side, where we've just categorically looked at two suppliers. So the colored area indicates the say band that each of these suppliers has as potential area of improvement compared to where they stand in the market. If you look at supplier 2, the band is much narrower, which indicates basically the second supplier is operating or providing motors which are more efficient and more mature in terms of technology, whereas supplier 1 has a lot of room for improvement. When we look at the e-axle market on a regional basis, we see a different picture that's painted in front of us. So if we start off with Greater China, we believe we will continue to see higher adoption of permanent magnet motors as time progresses. This is primarily attributed to the fact that they have an abundance of raw materials and access to production technologies of such raw materials for electric motors. So they are expected to continue this domination of usage of permanent magnet motors. But other regions, such as North America and Europe, are actively attempting to move away from this particular technology, with Europe being more keen towards ESM motors and North America towards induction motors. It's projected that in Europe, by 2035, 45% of the e-axle motors will not be uh, powered by permanent magnet motors. And there are a lot of significant announcements that have been made recently where non-rare earth based element motors are being developed in the North American region. To give you some more perspective on how the motor topology plays an influence in say different types of vehicles, we've just put out this chart where all-wheel drive and four-wheel drive vehicles and their usage of motor topology is provided. So as the all-wheel drive and four-wheel drive market grows, the role of induction motors is expected to evolve. So in this particular case, if you talk about Europe, if you look at the induction motors, the secondary drive within these particular vehicles is expected to have a significant uptake of induction motors, much higher than the primary itself. And if you talk about ESMs, these are more expected to be used as a primary driving source rather than as a secondary driving source. The story holds true for PMSM motors only, also, where we see a significant number of vehicles using PMSM as a primary drive. There are some vehicles that use it for secondary as well. These are say restricted to some of the high performance variants where performance is absolutely essential. Now, when we break this down into the North American region, we see a slightly different picture. We see that the induction motor has quite a big role to play here in terms of as a primary drive unit with as high as 83% by 2035, and it still plays a role in the secondary market, but it's more of a primary drive that it is seen. ESMs at this point in time do not have a market share in North America, but over time are expected to be used as both primary and secondary drive, but more favored as a primary drive. When it comes to permanent magnet motors, again, we see a similar picture where it's used as more as a primary drive, but also has good adoption in the secondary drives here because North America is a power sensitive market. So the high requirements for high power and high performance is something that will drive manufacturers to use permanent magnet motors, both at the front and the rear of such vehicles. So as the electric vehicle market is evolving, we expect certain use cases of e-axles to also come up into the market, which cater to say specific segments only. Uh, Say a couple of segments that we would consider here are the vans and the pickup market, which is a unique use case where the application of e-axle might not be as successful as in the case of say some other SUVs or some other segments. So we believe by 2036 that vans and pickups will contribute to about 10.43 million drive units on the whole. And for this significant number, suppliers are trying to develop a particular technology that's called an e-beam, which helps ensure that the towing capacity of the pickups and the vans are still maintained without any compromise. The idea here is to traditionally use the IC beam technology and then put in the motor and the inverter there so that the technology as a whole can be seen as a cost effective and a more efficient solution that can maintain the necessary conditions that are needed for such unique applications. If you see the chart on the left hand side, we believe that by 2036, about roughly 12 to 13% of the total addressable market is available for e-beams to be adopted. And if you see the market segmentation on the right hand side, we believe that by 2036, around 2 million units of e-beams would be necessary. The demand is primarily driven by the North American pickup market, with the van market in China following suit. There would be a small share of South Asia contributing there with some of the pickups that are used there. To give you a glimpse on some other raw materials that are fundamentally important for electric motors when it comes to permanent magnet motors, we've just indicated a couple of scenarios in the current slide and the next slide. So as mentioned, Greater China has an abundance of raw material, so it does not have any constraints in terms of say availability and processing of the same. But markets outside Greater China are understanding that neodymium is quite important when it comes to the electric motors, and this particular raw material may experience variations in its availability and market price. So in this particular scenario that is shown here, we've assumed that in a baseline scenario, the current market setup, if at all, were to move away from neodymium, these are the levels of improvements that we could see. But in a particular scenario where, say, for specifically for all-wheel drive and four-wheel drive vehicles, if we were to make sure that all of the secondary drives no longer use permanent magnet motors but use non-rare earth space motors such as induction motors or ESM motors, the amount of neodymium that can be saved by 2035 goes as high as 32.3%. So this is a significant amount of reduction that can be achieved if one or say suppliers were to choose other forms of motor topology. An added case that has been built on top of this is one where we've assumed a scenario where the smaller segments, relatively smaller segments, say the A, B, and C, and vehicles where the motor rating is less than 100%, if all of these vehicles also chose to go down the path of not using permanent magnet based motors and go for other forms of motor topology, another 12% reduction in neodymium consumption can be achieved by 2036. On the whole, we believe that by 2035, if all these say scenarios work out, then a reduction of about 45% in total in neodymium consumption can be brought about. Now I'd request my colleague Michael to take you further into the supply chain evolution. Over to you, Mike.
Thanks, Kartik. So yeah, let's spend a few slides exploring the supply chain, where the supply chain fits. I think it's certainly within the industry a big question around the balance between, let's say, in-house and outsourcing, OEMs versus the traditional supply chain. So let's take the full, and I'm going to focus initially here on the e-axle system. So purely that e-axle system, and we're going to look at four components: the system integrator, so who does the assembly of the motor, the inverter, the transmission for, say, a traditional 3-in-1. Then we'll look at the motor assembly, the rotor, and the stator of that, so the two components that make up the motor predominantly. So at the minute in 2024, we think that it's about 37% of that sort of complete vertical is done full vertical integration by the OEM. Now, a big chunk of that obviously is Tesla. A big chunk of that will be BYD, not exclusive to those two, but they're obviously taking up a big chunk of it as we stand in 2024. 63% will have some form of supply chain involvement. So that means the supplier could be doing, the full integration, the entire assembly and the motor and the rotor and the stator, or it could be that the supplier is just doing a stator. It could be that they're just supplying the OEM a stator, the OEM's doing the integration, the motor and the rotor themselves. Jump forward 6 years to 2030. OEM vertical, the numbers are going up. We showed that in the earlier slide. So the general volume and the piece of the pie you're getting is bigger. But as a percentage, that OEM vertical integration number is coming down. So we think there's opportunities here for the supply chain. As much as we hear a lot of noise around in-house, OEMs bringing everything in-house, there is still 70% of the market, we believe, in 2030 that will have some form of supply chain involvement. And again, I emphasize that could just be one individual component here or it could be the whole system. But 70% of the e-axle value chain, the full vertical of the e-axle, they're looking at the integration, the motor, the rotor, and the stator. 70% will have some form of supply chain involvement. Let me quickly pause just ever so slightly on the sort of BEV propulsion. Let's look at that hybrid P4. So how does it play out in terms of the e-axle as being supplier made for the hybrid P4, that 4.5 million that we saw of P4s being used in hybrid? As we look in 2024, it's about a third of it is done by the supplier and about 2/3 is done by the OEMs. So OEMs who are running hybrids in P4, about 2/3 of them have pulled this in-house. It does grow to just shy of 50% that we think the e-axle will be supplier made. So it peaks about 48%, you can see, by the end of this decade. So there is a bit of growth in that P4 market on the hybrid vehicles for suppliers. But again, it's this does feel like one that's in-house, and over 50% will stay in-house. So varies depending on which OEM goes down the hybrid route, of course, whether they're doing the e-axle integration. But like I say, the end of this decade, we think it will peak at about 48% for those hybrid P4s, those hybrid e-axles. Let's look back to the battery electric ones that we saw. So you can see that growth, excuse me, of summer 2024 approaching in this time about 70 million, about just over 60 million, sorry, by the time we get to 2032. We think this is a slightly different scenario. We think this has gone in-house, and we don't expect this to really be more of an optimistic scenario for the suppliers. So as we sit in 2024, 31% of this is done by the supply chain. So 69% is being done by the OEM in-house. And again, Tesla, BYD, Audi, BMW, big chunks of volume from some of these larger OEMs sitting in there. And again, the piece of the pie gets bigger, but we think that market share doesn't. We think that the market share, if anything, it holds around 30%, but we think it might drop below 30% by the time we get to the early part of next decade. 28% will be done by, the system will be done by the suppliers. So there is still a bit of opportunity there, particularly in some of the emerging markets and some of the emerging suppliers into the battery electric world who maybe don't have the expertise just yet. But fundamentally, we think the system integration has gone in-house, and we don't see it particularly swinging the other way on the battery electric side back towards the supply chain. So let's go one level deeper. Let's look at the electric motor. So the electric motor, as we stand here in 2024, we think about 43% of those are being done by the suppliers, the tier ones, and 57% therefore being done by the OEM. Jump forward to the early part of next decade, we think there is a bit of growth here as a percentage for the suppliers. We think we got it at 51%. Let's go just over 50%. So it's about halfway. It's about 50-50 split between in-house motor production being done by the OEM or outsourced to the suppliers. So a lot of opportunities there for the supply chain if they can be just a motor supplier and find an OEM to partner up with and who are doing the system integration themselves. Can you be just a motor supplier to them? Can you form a joint venture or some form of partnership there? Let's go to the next level deeper, the rotors and the stators. So the components, the active parts within the motor. This is where we think the real opportunity exists for suppliers. And this can be tier ones or this could be tier twos. We know for a fact there's a lot of tier two suppliers who are traditionally, say, just a motor core supplier to a tier one, who are thinking, okay, this presents us an opportunity. We have a motor core for a rotor. Can we partner up with a magnet supplier, or can we get a winding supplier to come in for the stator and move ourselves into being a tier one? We know there are some exploring this. We know that someone like POSCO have active plans and are going to have active plans to do this and become direct tier one, presumably with POSCO to Hyundai. But what does it look like at the minute, and where is it? It's about 59-60% as we stand in 2024, and it will go over 2/3 of the market by the time we get to the early part of next decade, 2031, 2032. So big opportunities for the supply chain here. The word we always hear when we speak to tier ones and tier twos is is flexibility. You have a production line that's running rotors and stators at the minute to then go into a motor. Maybe you just need to keep that production line going, and maybe you do become just an active parts supplier of just rotor or just stator. It's something not limited. We think about the e-axle value chain. Let's switch and pivot slightly to the power electronics. The inverter has a similar trend beginning to emerge of OEMs pulling design of this in-house and looking for partners on the active parts like circuit boards or power modules. So it's not exclusive to e-motor, but e-motor is certainly one of the components that this seems to be fully a trend that's embedded now and is growing in the supply chain. So I want to just spend a couple of slides looking at the role of Greater China. It's a question we get asked a lot, particularly here in Europe. We do seem, there's a lot of noise around the presence of Chinese OEMs, but what about the Chinese presence within the electric motor supply chain? So Greater China, it has obviously, as people within the industry will know, it has a real hold on the permanent magnets, and Kartik's already explained earlier the role of permanent magnet versus some of the other technologies. Greater China motor production, and this covers all forms. So this is non-P4, hybrid-based motors and P4 battery electric. China will peak at around 50 million motors being produced in the middle part of next decade. So you can see that there. It's a continued growth, but a slight leveling off towards the early to mid part of next decade. In terms of what's for domestic use, I touched upon the level of imports and exports earlier. Greater China will have a big reliance on domestic production. So 84% of those motors that are produced in China will be used for domestic use. And I think we touched on earlier, a very, very small amount of imports, a little bit from some of the Japanese OEMs as they look to move into China for battery electric vehicles. Exports, therefore, it's about 10 million. You can see peaking in the middle part of next decade. 6% of the total production, if we take 2030 as a reference point within this. So in 2030, 6% of the total production of motors being done in Greater China will be exported to Europe. And 40% of all of the exports coming out of Greater China will be exported to Europe for the electric motor. So Europe, we saw earlier, it's got big production levels coming, but it does have a reliance on China. There's an element of this of European manufacturers looking for lower cost. There is obviously the elephant in the room of Chinese OEMs coming into Europe and exporting their motors from Greater China to be used in vehicles here in Europe that are going to be produced in Europe. We do anticipate potentially some legislation coming in the next couple of years that tries to mitigate some of this and maybe drives them to produce in Europe. But at the minute, that legislation obviously doesn't exist, or it's not existing in forms that would stop this sort of these numbers that we're seeing here. Let's go one level further down. Let's look at the rotors and the stators. Like we say, it has its big monopoly over the permanent magnet form. So 44.4, 44.3 million rotors and stators being produced in Greater China. This is where we think there's a bit more of an exports coming to Europe. So this time, 10% of the total production will come to Europe, and 57% of all of the exports coming out of China will come into Europe. We know of many, like I say, many Chinese OEMs who are coming into Europe who will leverage their supply chain in China. We do also know of not a lot, but we know of a few suppliers based here in Europe who are now looking for partners in China for cheaper rotors or cheaper stators that they will look to do print to build. They will have the design in-house and they will actively look to do print to build with a partner in China. So it's definitely a trend that we're seeing. It's definitely something that's here, and it's probably going to be here to stay unless we see some legislation to mitigate it. But certainly when cost is one of the driving factors earlier on the consumer sentiment, we need to get the cost of electric vehicles down, then looking at ways in which you can reduce the cost of the motor. Maybe production outside of Europe or production in China is going to be the way forward for a few people. So a quick summary, the e-axle market, even though we're hearing lots of noise around the slowdown of battery electric vehicles, we still are on that path. in the major regions of Europe, North America, Greater China towards battery electric. And the e-axle market is expected to exceed 73 million units by the time we get to 2035. As Kartik has touched upon, there's many design parameters that are hot topics at the minute. Power density and efficiency are two of the big ones that are underpinning the design in the last 12 to 18 months for these motor designers. And there's many emerging technologies, as Kartik has spoke about, that are playing their part in improving the power density or improving the efficiency. Rare earth-based magnets are still the most efficient and still the dominant choice if you can have them and you've got a good solid supply chain. However, that question mark around potential supply chain issues or accessibility to getting these rare earth-based magnets, it exists. And it does seem maybe certain regions looking towards evolving the supply chain or moving towards new technologies. The trend of vertical integration, it exists. Larger OEMs are going to continue this. But like we touched upon, we think around 49 million e-axles are still going to have some form of supplier involvement by the time we get to 2035. Again, that could be just a small component of the rotor or the stator, or it could be the full system integration. We touched upon those components. Like I say, I don't limit this to the motor. There'll be a lot of people here looking at the inverter side of these e-drive units as well. Active parts, particularly design of these parts coming in-house and the active parts being produced by the suppliers, is definitely a trend that's here. And it's definitely something that we see emerging in the supply chain and growing in the supply chain in the next few years and into the next decade. And finally, Greater China. Greater China it plays a significant role within the electric motor market, significant role within the electric vehicle market in general, and we expect that to continue. We do not see that diminishing unless we see significant legislation to mitigate that. Europe, in particular, we think will lean as a region. We think will lean on them in reasonable numbers for some of the subcomponents and the motor assembly. At that point, that's it from me and Kartik in terms of the content. There is a Q&A coming. So yeah, I think these slides will be sent out. There's my details, there's Kartik's details if you want to get in touch with us after the session, or if we don't get round to your question during the Q&A. At that point, I will hand back to Alexandra, who will kick off the Q&A session for us.
Yeah, thank you, Michael and Carter, for your insightful presentation. The information was incredible, valuable, and relevant. We'll now begin with the live Q&A session. I encourage our audience to submit their questions via the Q&A tab, and I can already see a few coming through. So I will read the first one and then I will hand over to you both. Thanks. So the first one, how are new materials impacting the performance and weight of electric motors? Thank you.
Thanks, Alexandra. So that's a great question. So as we discussed, there's been a lot of development where suppliers are keen to move away from rare earth elements. So over time, they have tried to reduce this dependence by developing motors that make use of lesser quantity of rare earths while maintaining the same performance level. And alternatively, of late, there has been a lot of interest around ferrite-based magnets, where people are looking to understand if permanent magnet motors with ferrite magnets can achieve the same level of performance or not. And there are a few trade-offs that come into play, because to achieve the same power rating, the motor or the say entire drive unit package becomes much bigger. But again, motor designers are trying to find say more creative ways by increasing one of the parameters such as speed to ensure the package remains say comparatively smaller. But again, mechanical durability and structural durability is something that they are looking to improve as time progresses.
Perfect. Hopefully that answers the question. Obviously, like I say, if it doesn't, either let us know in the chat now, or please do follow up with us, with Kartik or myself after the session. Kartik, I think there's another one sitting here that's more in your remit, and that was, what advancements in electric motor technology are currently being explored to enhance the overall efficiency of EVs?
Okay, that's also a great question. So there are a couple of key parameters that are being looked at. One being the winding topology, where a lot of suppliers have understood the benefit that a hairpin winding brings into play. So that's why they've started to shift away from insertion winding because of better fill factors that hairpin windings offer. which eventually helps improve the efficiency on the whole. At the same time, dependence on rare earth is something that is again dropping, but a lot of say effort is needed in that, because there are certain suppliers who have this plug and play solution where they're able to achieve the same power levels by moving to say other forms of non rare earth based motors. But these two are the key areas at this point in time. Apart from motors, then just to ensure the system efficiency level, there is this big uptake of silicon carbide that's coming up, which is ensuring that inverters also play a crucial role in as a subcomponent to improve the overall system efficiency.
Perfect. Great. Thanks, Kartik. Couple of questions here. Can we replicate these slides at the end for Europe and North America? Yes, we can. Let's take that offline. Please do reach out to us, and we can get around to supporting you with that analysis. Question here. You mentioned the role Greater China plays within this industry. How do you anticipate tariffs will impact their role in European motor supply chain and production? Great question. It's probably the big open question that sits particularly around, we've got Europe here, but particularly with what's happened in North America as well in the last couple of weeks with the election, something we're grappling with in that market as well. I would say in Europe, I touched upon it a little bit during my slides. We do think there will be some legislation coming in probably 2026 is our anticipated time frame. It could be a little bit earlier, depending on a lot of different parameters. It could come earlier. We think probably 2026 we'll see some sort of legislation that tries to replicate what we see in North America, which is European production for these motors, or at least the sourcing of the materials, the sourcing of the motors. Let's see where it ends up. We've already got the Critical Materials Act, which tries to do that. I think we will see that legislation. Now, the big question, I guess, that sits for suppliers around that is, does that present opportunities then? If Chinese OEMs come and produce within Europe, or let's say they want to sell their vehicles that are produced in China in Europe, does it present opportunities for traditional tier ones based here in Europe to go and work with those? Or do we think the Chinese supplier base will simply come and build production facilities within Europe, and that will be a way in which they get around this? I think the answer is somewhere in between the two. I think it will present some opportunities, but we do know already that there are, certainly some motor-based companies who are actively either in the ground building or are very close to putting that spade in the ground, certainly in Eastern Europe, for motor production. So it will have, tariffs will play a factor. Let's see how far they go, but we do think there will be some legislation that tries to do more of a made in Europe, let's say, approach to electric motors and some of these components. But let's see, does it present opportunities for existing European Western tier one suppliers, or is it more of a chance for Chinese suppliers to grow their footprint here in Europe? Kartik, one question I think to go back to you. Do you have any insights on the choice of insulation material for the copper wire?
I think I'll need to check on this once to respond.
I think the answer to this is, at the minute, no, we don't. We have some views on it, but we don't have any real data to show. So maybe to whoever sent that question in, maybe just connect with us afterwards, and we can have a chat with you around some of our views on that. Let me just have a quick look. So Kartik, maybe another question for you. What's happening with synchronous reluctance motors?
Okay, so when it comes to electric vehicle uptake, the three topologies that we listed are garnering more importance because they on the whole have much higher benefits. The issue with SRMs mainly is in the form of torque ripple and the low power density that it offers, which sort of puts it off when it is compared to the other three topologies. That's why a lot of say resistance, although there are certain benefits in the form of say structural reliability and say it's a permanent rare earth free design as well. But when we look at the bigger picture, when we try to see if it ticks all the boxes, there are a lot of boxes it does not tick, because of which it's not pursued as aggressively as the other three topologies are.
Great. Let me pick this one up. There's a couple of questions here around motor voltage rating, and do we see the voltage rating going? What do we see the trend towards higher voltage than 800 volt potentially, or where do we see 800 volt? So we think 800 volt is coming. Kartik touched upon in his question earlier, silicon carbide. We think that will be as a consequence of the 800 volt growth that we're going to see. 800 volt obviously have its benefits in terms of the charging performance you get and a few other parameters. So we don't think it will be, we don't think that the market is going to go 100% 800 volt anytime soon, but we do see it growing in pretty big volumes, particularly in premium, high-end battery electric vehicles, where maybe the cost that you can absorb the cost of the add-on cost of the system. So we certainly do see 800 volt coming. If we look here in Europe, certainly if we think about the big German OEMs, as far as we're aware, they're not really outsourcing for 400 volt anymore. It's predominantly 800 volt that they want to be awarded or for people to bid on. Higher than that, we do have a few in our forecast. I think Toyota is one of them. Approaching 1,000 volts. At the minute, it's quite limited in terms of what we've got in the forecast for anything above 800 volt, but certainly we don't rule that out. And we are seeing ever increasing trends on the power electronics running up higher voltage for the components. So it maybe does lend itself. But I think at the minute, the predominant one we've got is 800 volt, but there is a few small applications going upwards of about 1,000 volt in the forecast. There was a question here on the trend in power semiconductors. So slightly away from the motor, but let me pick that one up. We're actually doing some research on this at the minute around diving, like we've done on the motor, diving into the motor to dive into the inverter and some of particularly the power module within the inverter. So I think the trend is more towards power modules within the inverter now, with the requirements and the power requirements from the inverter of what's needed. It tends to be more power modules. But certainly, yeah, please do reach out to us because I think we can give you a bit more detail around the new research we're doing there as we go further into the inverter, and that will be published early part of next year. So Kartik, maybe loop back one final one potentially for you. Let's see if any more come in. Do you foresee the use of alternate winding conductors like aluminium gaining market share from copper in the next decade? So do we think we'll move towards aluminium winding instead of copper?
That's an interesting question. So we do know that the conductivity of aluminium is, say, not as great as what copper offers. So on the whole, through the discussions that we've had with the industry experts and quite a lot of universities, we found that it seems to be a long shot because the performance of the motor again goes for a toss, and efficiency being a very key attribute at this point in time pushes the picture or the narrative in such a manner that the use of copper makes more sense. And till the day you say suppliers are not able to come out with a solution that can give the same level of efficiency for the same size of package, we do not foresee this picking up much pace. With that said, there might be certain segments such as low cost vehicles where performance might not be as essential, where this could find a potential place, but the industry on the whole is not severely focusing on this at this point in time.
Great. Yeah, one that it slipped off the radar, but I saw it while you were speaking earlier, Kartik. There was a question around North American exports versus domestic usage in North America for the motor production based on the earlier slide. So we think North America is very much moving towards being a regionally dependent area. Now, there could be some elements of that because a lot of the motor production comes from Mexico. So again, let's see where the policies shift there in the next couple of months and years. But certainly we think North America, if you look back at those slides, very, very small amount of exports going out of North America. What's being produced in North America is predominantly going to be used for the North American market. That's not to say there isn't some that goes outside, but I think predominantly if it's produced in North America, it will be used in North America or will some small exports going out. But we think that is a market moving more towards regional independence, and I think realistically it's probably going to head more towards that path in the next few years at least. maybe time for one last question here that I've just seen. The IC trend, so I presume the inverter trend move towards gallium nitride. For the inverter, we don't think that's gonna happen. We still think there's so many limitations holding gallium nitride back on the inverter side. For the DC-DC converter and the onboard charger, we do have a team who look into that. They maybe tell you a slightly different story where they think there is more of a potential for gallium nitride to come in there. But certainly on the inverter side, we think it's silicon carbide based. The one thing that we probably would see more of, and we know that there's more than a few semiconductor chip companies, power module companies developing this, is the combination of silicon plus silicon carbide. Now, you saw that, in the press recently, there was an announcement from Infineon running with a Chinese OEM that they've built an inverter that runs silicon plus silicon carbide, a mix of the two. So I think that's more where the trend is going to end up on the inverter side as opposed to gallium nitride. So on that note, I think we are at the hour. I think there's a few questions that we haven't got round to, so we will follow up and reach out to you after this, or please do, if you have any other questions or anything you want to discuss with Kartik or myself, the email addresses are in the slides that will be sent out, and we'd love to connect with you after this session. That would be great.
Thank you. Yeah, as Michael said, please reach out to the speakers directly or contact us directly, and we'll ensure that those questions will be answered. Thank you, Michael and Kartik, for your excellent presentation. I hope our audience found insights and knowledge shared today valuable. A big thank you as well to everyone behind the scenes who work hard to make this webinar a success. As mentioned earlier, this webinar will be available on demand on our website, and we look forward to seeing you all the next CWIEME Tech Talks. Before we wrap up, I would like to remind our community that the CWIEME Berlin call for papers is now open. We invite you to submit your paper for a chance to present at CWIEME Berlin, taking place from the 3rd to the 5th of June 2025. If you have any questions, please feel free to reach out to me directly. Thank you all, and see you next time.